Okay, I'm going to take you through metabolic equations like we're going to do in a lab. And we'll start off with a walking equation. And the walking equation is really good for speeds starting at 1.9 miles an hour and going up to 3.7 miles an hour. So this is your equation for estimating oxygen uptake. And you have a resting component, which is 3.5. You have a horizontal component, and with this, it's 1.0 times the speed, and it's the speed expressed in meters per minute. And then you have a vertical component, and to find this, you take 1.8, multiply it by the speed, again in meters per minute, and multiply it by the grade expressed as a decimal. So let's do an example. So if speed is 3.6 miles an hour, and the grade that the person is walking at is 5%, what is the estimated VO2? So we already know what the resting is, and that's always going to be 3.5. We need to determine what the horizontal component is, and in our example, the person is walking at 3.6 miles an hour. To convert it into meters per minute, what we need to do is take 26.8 and multiply it by 3.6, and you can do that calculation. I got 96.5, so that's 96.5 meters per minute. And now what we need to do is multiply it by 0.1, and for the horizontal component we get 9.65. For the vertical component we have 1.8, multiply it by the speed that we just determined, so that's 96.5, and then multiply it by the grade expressed as a decimal. In this case, 5%, the way that you express it as a decimal is 0.05. So you multiply that out, and for the vertical component, we get 8.7. So then to solve for somebody walking at a 3.6 miles an hour speed and a 5% grade, we take our resting, 3.5, plus our horizontal, which is 9.65, and then add it to our vertical, which is 8.7, and that comes out to be 21.85 milliliters per kilogram per minute. Running is ideal for speeds 5 miles an hour or greater. So then the question I guess you might be asking is, what if I have somebody that comes in and you put them on the treadmill at 4 miles an hour? Well, this is where you have to make a choice. So if the person is truly walking, then you would use the walking equation. If the person is jogging or running, then you would use the running equation. And the running equation is very similar to the walking equation. The only difference is that we have the constants that are in that vertical and the horizontal component are a little different. So it's 0.2 times speed, and the other difference is the 0.9 times speed times grade. So let's go ahead and do an example. Say that somebody runs at 5.5 miles an hour and the grade is 3%. Let's go ahead and estimate VO2 in this case. So the horizontal component is 5.5. We need to convert it into meters per minute. So we take 5.5 times 26.8, and when I did the math it was 147.4. So then you take that and multiply it by 0.2, and our horizontal component is 29.48. To get the vertical component, we take 0.9, multiply it by that speed, so 147.4 meters per minute, and a 3% grade is expressed as 0.03 as a decimal. We multiply that together, and I'm going to round up in this case, so it's 4. So you solve it, so 3.5 resting, 29.48 horizontal, 4 vertical, and we're going to estimate that at that speed and grade combination they have an oxygen uptake of 36.98 milliliters per kilogram per minute. So the last thing that we'll talk about is cycling. And the cycling equation is a little bit different. We have our resting component, which is 3.5. Since there is no vertical component, we're on a cycle, we're not going forward, we also add in essentially a resting oxygen uptake for that component, so that's 3.5 as well. So then the only thing that we need to worry about is the vertical component, and that's the work that your legs do as they're going up and down on that cycle ergometer. And the equation for that part is 1.8 times the work rate divided by the body mass in kilograms. And what we need to do is determine work rate first. Work rate is the resistance that you apply to the cycle, so in kPs, the distance of the flywheel, and multiply it by the revolutions per minute. So let's do an example. So a 132-pound person cycles at 3 kPs, and they're at a revolutions per minute of 50. So there's your reminder of how to calculate work rate. Let's plug in a few things. So from our example, the person was cycling at 3 kP, so we plug that in. The cycles that we have in the laboratory are Monarch cycles, and they have a distance of 6 meters around. So we're going to use 6 as distance of the flywheel, and you're going to use that in your calculations as well. And then the revolutions per minute was given at 50, so you multiply that out, and that equals 900. So then to find the vertical component, we take that 900 work rate, Alright, sorry about that. I just realized that I had a mistake in this PowerPoint. So we're going to take that 900 work rate, multiply it by 1.8, and then divide it by 60. And that's 60 kilograms. So if you take 132, which was the person's weight, and divide by 2.2, you'll get the weight in kilograms. So once you do that, then you have a vertical component of 27. Then you add everything in together. So 3.5 plus 3.5 for our resting and our horizontal, and the vertical component of 27. And you have an estimated VO2 of 34.